Our next topic, as we continue studying gases and gas laws, is known as the ideal gas law. So remember when we first got our introduction to gas laws, we talked about the difference between an ideal gas's behavior and a realistic, real world gas behavior. So you can refer back to those little differences if you need to. And let's take a look at the ideal gas law. So we are going to circle back around to Avogadro. So we met Avogadro. He provided us with Avogadro's number, which allows us to convert between the moles of an atom or a molecule or a unit into a counting number like units or molecules. Okay, and what Avogadro discovered is that equal volumes of gases contain equal numbers of moles if you keep temperature and pressure constant, and that this is true for any gas. And so we get Avogadro's Principles equation. But we're not going to use this in and of itself. We need to combine it with more information. So what we can do is we can merge the combined gas law with Avogadro's principle. And what he discovered is another constant known as the universal gas constant, which is represented by the letter R. And here are your numbers here for the letter R. So add this equation and these constants to your equation sheet that you have, your growing equation sheet, because you will not need to memorize these constants. Okay, so just have them on that sheet so they are nearby and quick and easy for you to discover. Okay, now which number do you need to use? Well, that depends on what you're given in the problem. If you are given liters and atmospheres, you will use this first one. However, if you are given decimeters cubed and kilopascals, you'll use this one. So it just depends on what units were used to measure your gases during the problem. Okay? All right, so our official equation is PV equals nRT, also known as the Pivnert equation. They call it the Pivnert. Okay, the ideal gas law is also Pivnert. So let's remind ourselves what each one of these letters stands for and what goes there. And this is something you may want to write out on your equation sheet as a reminder. So remember that P is for pressure. P is for pressure, so that will either be in atmospheres or kilopascals. V is your volume. So that may be centimeters cubed, which if you're given centimeters cubed, you'll need to convert it to decimeters cubed. This could be liters, okay, or milliliters. If it's milliliters, we got to convert it to liters. Okay, N for this equation is going to stand for your moles. Okay, this is your moles. Sometimes the problem will simply give you moles. Sometimes you will need to calculate moles using those previous skills that we have learned before. R is your universal gas constant, so one of these two numbers, depending on what units you're working with. And then T is for temperature. And remember, with gas laws, we always use Kelvin for your temperature. Okay? All right, so let's look at a practice problem. Calculate the pressure in atmospheres of 0.412 moles of helium at 16 degrees Celsius and occupying 3.25 liters. Okay, so let's work it out and let's start by analyzing, okay, what do I know? What do I need to know? Okay, so just pulling from that word problem, we know that the pressure is what I want to know. Calculate the pressure in atmospheres. So that's my question mark, that's my X, atmospheres. Okay, I have moles. That goes into the N of my equation. I have 16 degrees Celsius, but this is a gas law, so I'm going to convert that to Kelvin by adding 273 to it, so 16 plus 273 is my 289 Kelvin. And my volume is right here, 3.25. Okay, so what else do I need for the Pivnert equation? I need my R. So I take a look at my two R's and I say, which one do I need? Well, in this problem, I need my answers in atmosphere, and I have liters, so I need 0.0821 because that has liters and atmospheres. Okay, next let's plug this in to the equation. Okay, so P is my unknown, so I'm going to leave the P there. My volume, 3.25. My moles for my N, 0.412. My R, and my temperature. Okay, and I have left my units up here so we can see. So remember, as you keep up with those units, whenever we divide by the same unit, we are able to cancel it off. Okay, and so to get the answer that I got here, what did I do? I started by multiplying these three numbers together to see what I get. So multiply these three together, and that's going to, since moles and Kelvin are on the bottom here, and I'm multiplying by mole and Kelvin, my mole and Kelvin are going to cancel off. Okay, and I'm left with liters and atmospheres, so multiply all three of those. Then, since my 3.25 is multiplying by P, do the opposite. So divide both sides by 3.25. So I take my answer I had, divide by 3.25 liters. That makes my liters cancel off, and I'm left with atmospheres. Okay, and my final answer is 3.01 when I round for my proper number of sig figs. And actually, now that I'm looking at the problem, I see that that's actually wrong because 16 degrees Celsius is 2 sig figs. So my answer should have 2 sig figs. So the proper final answer is 3.0 atmospheres. Okay, let's do another example problem. Okay, so find the volume of 85 grams of oxygen at 25 degrees Celsius and 104.5 kilopascals. So what do I know? Okay, I want to know the volume. Find the volume. Okay, I have 85 grams, so I know that's going to go towards my moles, but I'm going to have to do an extra step there to calculate my moles from my grams. I have my temperature, 25 degrees Celsius, but we always have to convert to Kelvin, so add 273. I have a pressure, it's in kilopascals. Okay, so which R do I need? Because I've been given kilopascals, I need that second one, 8.315 decimeters cubed kilopascals. Okay, so they match. Okay, all right, so let's start working. So I can't just plug this into my equation yet because I don't have moles. So I need to use my old skills that we learned a while back in calculating moles. Okay, so I have 85 grams. How do I convert from grams to moles? I use my molar mass. Where do I find my molar mass? The periodic table. Okay, so I take my known, 85 grams. Then I look at my periodic table. I have O2. My periodic tells me that oxygen is 16.00, but I have two oxygens, so 32.00 grams per mole. Okay, my grams cancel off. I'm left with moles, and I just divide. 85 divided by 32 equals 2.7. So I can add that over here because now I have my moles for my N. So I had to do that extra step before I could use the full equation. Now we can plug all of these numbers into that Pivnert equation. Okay, I have a P, my V is my unknown, I have my N, which I had to calculate, use my periodic table and molar mass, my correct R because I was given kilopascals, and my K temperature. Okay, to solve this, simply multiply these three numbers together and then divide by 104.5. Okay, round for sig figs. I have 2 sig figs in the problem. Those are my least, so my answer should have 2 sig figs, so 64. And my unit is decimeters cubed. If we keep up with that unit, okay, we'll see that the moles and the K cancel out when I multiply, and my kilopascals cancel out when I divide, and I am left with decimeters cubed. Okay, so when you get ready for your independent practice, that's what you need to pay attention to. Pay attention to those units. The answer you provide should match the units in the problem. Okay, so if the problem gives you decimeters cubed and you're answering in centimeters cubed, you're not going to get that answer right. If you're answering in atmospheres when the problem gave you kilopascals, you're going to get that answer wrong. Okay, so you're going to get that unit point taken off. So make sure that you are following through with your units. If you did not get these answers, get into contact with me so I can help you. If you don't know anything, like you have no idea what's going on, you're totally lost, get into contact with me so I can help you out, because now it's time for some independent practice.